Whoa, JT's sure got momentum there.
Wait, what's momentum?
I don't know, you go look it up.
So, JT, have you found any more information on momentum?
Oh, what's this, JT?
That's nothing.
Yeah,
Don't worry about it.
that's what I thought.
But I did find that momentum is the quantity of motion that an object has.
What?
Alright, so we know that all objects have a mass, right?
Yeah.
So then if an object is moving, it has momentum. It's a measurement of how much stuff is moving and how fast it's moving. So it says here, if we want to calculate momentum, we want to multiply mass and velocity. But in physics, the symbol for momentum is P. So I guess it would look something like this.
Oh, so because momentum deals with velocity, it's a vector quantity, right?
Right.
Yeah.
Alright, well this is boring, let's go play football.
Woo! Sports!
So, we know that momentum is just an object in motion. So if JT runs at me, he has momentum. Or if I run at JT, I have momentum. But what if we want to change momentum? Well, we know that a change in momentum is equal to a force times a time interval. So you can change your momentum in two ways. First, we're going to try a small force for a long time interval. Or, you could do a large force for a small time interval. Either way, your momentum is changed.
In a collision, the momentum change of object 1, or the cue ball, is equal to and opposite of the momentum change of object 2. That is, the momentum lost by object 1 is equal to the momentum gained by object 2. In most collisions between two objects, one object slows down and loses momentum, while the other object speeds up and gains momentum.
Here, Frank is going to demonstrate that the cue ball will lose momentum, and the pool ball is going to gain momentum. As we just saw with Frank, when two objects of the same mass collide, their momentum is conserved. One object gains momentum and speeds up, while the other object loses momentum and slows down. But what happens when you take two objects of different masses? Here we have a cue ball and a pool ball. The cue ball has a slightly greater mass than that of the pool ball. So now JT is going to collide the pool ball with the cue ball. As you can see, both objects moved in the direction that the cue ball was originally moving in. This is because the cue ball has a slightly greater mass than that of the pool ball. Therefore, it loses less momentum than if it had collided with an object of the same mass. Let's try it again, but with a more drastic change in mass. This time we'll collide a pool ball with a tennis ball. The cue ball and the tennis ball obviously both move in the direction that JT threw the cue ball in. The cue ball does not stop moving because it doesn't lose all of its momentum. The cue ball weighs a lot more than the tennis ball, and the tennis ball weighs a lot less than the cue ball. So when they collide, the overall momentum is still conserved. However, the movement of the two objects differs because of the difference in masses. Now, let's try it between a cue ball and a ping pong ball. Here again, the cue ball and the ping pong ball are moving in the same direction. If the cue ball and the ping pong ball had the same mass, the cue ball would stop while the ping pong ball would move forward. However, since the cue ball has a greater mass, it's going to continue in the direction and lose less momentum than that of a collision between two objects of the same mass.
What's this,
Oh,
JT?
that's not.
That
That's
doesn't
not.
look nice,
But I found that momentum.
So, JT, have you found any information on momentum yet?
Yo, let's get here. If we want to calculate momentum, we need to multiply mass and velocity.
Oh, so because it has velocity, it's a vector quantity, right?
Bitch, she messed up. But I found that momentum is...
Fred, you're lying.
Wait, oh, I thought we were waiting. Oh, so because momentum deals with velocity, it must be a vector quantity, right?
Fuck you, I feel it is my obligation to Mr. Troy, a fellow KGB agent, to report on our competition, or so-called competition.